Okay, guys, let's do it. I am now on the end of page 71, just reading that little passage, and then we're going to go on to the last example and then just do one more book example. Okay, so let's take a look here. So again, we are on page 71. Okay, while simple random samples give each group of n individuals in the population an equal chance to be selected, they are not always the easiest to obtain. Several other sampling methods are available that can be used instead of SRSs. If this population consists of several groups of individuals that are likely to produce similar responses within groups, but systematically different responses between groups, consider taking a stratified random sample. You heard about this in the video. We didn't go over it in the slides really yet. To do this, select a simple random sample from each stratum group to obtain the sample. Another method is called cluster sampling, which divides the population into smaller groups that mirror the overall population and select a simple random samples of the actual clusters. All right, so stratum is basically if there's a specific characteristic, like when we talked about you can divide a high school into freshman, sophomore, junior, senior, and then you take a simple random sample, basically a freshman, sophomore, junior, senior, and then you would take a simple random sample from each of those classes. Let's say you take 4 people from this class, 4 from here, 4 from here, 4 from here. That is my actual sample right there. So that's kind of what stratified random sampling is, and we'll go into more detail later. Cluster sampling is more just for convenience or lack of money. So if we had the same situation, we had a high school right here, we would just, like if it's cluster sampling, what we would do is we would just randomly, we would, first of all, we would set the high school all into clusters. We have a whole bunch of clusters right here. And not by class, not by any characteristic, just like a bunch of, just by area, just clusters. And we would take a simple random sample of those clusters. So maybe we would take this one, this one, this one. And then all 3 of these actual clusters right here are now our actual random sample right here. We just take everyone there, and that's our actual, that is our simple random sample right there. Or that is our sample, I should say. So it's a little different, and I'll go more into detail with this later. When designing a sample survey, random sampling helps avoid bias. But there are other kinds of mistakes in the sampling process that can lead to inaccurate information about the population. For instance, if the sampling method is designed in a way that leaves out certain segments of the population, the sample survey suffers from undercoverage. When selected individuals cannot be contacted, or maybe they refuse to participate, the survey suffers from non-response. If people give incorrect or misleading responses, a survey suffers from response bias. Okay, so a couple situations here. Now, it's important not necessarily really to memorize, like, the vocabulary terms would be like non-response, or under coverage. Not necessarily, it's important to know that, but it's more important to know what's actually happening and how this is affecting your survey. So right here, for example, if there's a whole, like we gave that with the example with just voting in general, a lot of people who do not vote, they have a common characteristic, all right? And so that right here is going to affect the overall, in this case, like if you consider an election an actual survey, that affects the overall survey. So that's what's, what they're talking about right there with under coverage. In a voluntary, voluntary response survey, selected individuals can't be contacted. Maybe they refuse to participate. That's what they're talking about with non-response. And lastly, if people give incorrect or misleading responses, the survey suffers from response bias. Finally, if a question is worded in a way that favors certain responses, that survey suffers from question wording bias. Be sure to design sample surveys to avoid these issues and make sure you can identify them in existing studies. All right, let's look at an example. A simple random sample of 400 recent high school graduates was asked, did you ever cheat on an exam during your senior year. Of the 400 respondents, 64% admitted to cheating on at least one test. What is one practical problem with the survey? All right, obviously, right here, a lot of people are not going to be truthful about cheating on an exam. So this is kind of like a right here. This is actually more like whether people are actually going to be honest right here. This actually goes back to right here. People give incorrect or misleading responses right here. That's right here. This is the example of a response bias. In this case right here, recent graduates may not be truthful when asked if they cheated during their senior year. So you don't have to actually say this is response bias. You just have to explain right here. Recent graduates may not be truthful when asked if they cheated during their senior year. A lot of people won't be truthful though. What's the likely direction of this bias? So we think actually probably it's higher than 64. So that means that 64 would be an underestimate. So this is likely an underestimate of the poor proportion of recent graduates who cheated on at least one test. The actual proportion is likely higher than 64%. Okay? All right. So if you're filling this out, you could pause this right here so you can fill this all out. But it's actually an easy question, nothing too difficult. All right, I'm going to go on to 4.1, number 13, because I want you guys to actually know right here. Let me erase this. I want you to know that sometimes there may be a question where we're going to use a random number generator to do a simple random sample rather than just giving a table of numbers like we did in the previous example in the previous part of the workbook. So let's take a look here. To gather data on a 1,200-acre pine forest in Louisiana, the U.S. Forest Service laid a grid of 1,410 equally spaced circular plots over a map of the forest. A ground survey visited a sample of 10% of the plots. Explain how you would use a random number generator to choose a simple random sample of 141 plots. Your description should be clear enough for a classmate to carry out your plan. All right, first of all, remember, label, randomize, select. That didn't go away. That's still there. Okay, so label, randomize, select is all there. All right, so first of all, we're going to start with the labeling part right first. We will label all of the plots from. Now, in this case, we're using actually we're going to be using technology in this case. We're going to use a random number generator. So we don't have to worry about digits. We don't have a table of values. So we're just going to go ahead and label them from 1 to 1,410. It does not matter if we have, 4-digit numbers, or it doesn't make a difference. We're using technology now. Okay. Now, next, what we're going to do is we're going to use our TI-84. So we're going to use the TI-84. And we're going to use right here the command. And this command is right here, and I'll show this to you in a second. It's going to be rand int. Okay, and right here, and what you do is you just choose, you just want them to come up with a random integer, and what you do is you choose the two numbers right here, the minimum and the maximum of what you're looking for right here. So in this case, we want something between 1 and 4,010, so I'll say 1 and 1410 right here. Okay, and this right here gives you the whole range of values right here of what we're using. Okay, so no problem. All right, and then right here, we're going to use rand int and right here to select 141 different integers. All right, from 1 to obviously 1410, 1,410. And we will select the corresponding 141 plots. Okay, so in this case, you have to ask yourself, does it matter if I have a repeat right here? Because remember, repeat was an issue before. So we always have to look at the problem and see right here. we know we're not going to have a problem. We're only going to be using values from 1 to 1410. But let's read this problem. The U.S. Forest Service laid a grid of 1,410 equally spaced circular plots over a map. We want to use a random number generator to choose a simple random sample of 141 plots. Okay, so we actually, in this case, yes, we don't want to get the same plot twice right here. Okay, so we will throw out any repeats. Okay. All right, something like that right here. And then that will give us, we'll select the corresponding 141 plots, right? Because at first they're just labeled, so we want to actually select them. So that just gave us right here, that goes back to we labeled them, all right? We used rand int, and then we selected at the very end, okay? B, use your method for part A to choose 3 plots. Let me show you how you do that. We want to choose 3 plots. So let's see here. So we put our calculator. We're going to use this right here, clear it out. Okay, so no problem. So we're going to go to rand int. So we go to stat right here, and we are going to, oh, actually, I think it's math. I'm sorry about that. Math probability, my fault. There it is. Sorry, it's been a while since I've done this. It's math probability. So scratch what I just said, and there we have it right there. Rand int is what we're using. So once again, just to show you what I did, I press math, and then I go all the way right here to probability. You can just go to the left right there. It's PRB, and there it is, rand int. Okay, and again, we're just going from 1 to 1410. I'll close that guy up. And now here, they just wanted to come up with 3 plots, obviously 100, so it's going to just give a number each time. So the first number we come up with is 1331. All right, the next number we come up with is 1,281. And the next number we come up with right here is 207. That's it. Okay, so that gives us actually right here this right here, we're going to, from part where that's the first 3 plots that we're going to choose, okay? We'll choose right here, plots 1331, 1281, and 207. That's it, all right? So it's a little bit simpler with technology, but that's about it. All right, have a good day, guys.